In my last video, I explained the conditions necessary for static equilibrium and how this can be used to find the forces present on different objects. In this video, I wanted to go over a simple example. Suppose that a 15-meter long 1,200 kilogram support beam supported by two vertical columns holds a 7,000 kilogram oven 6 meters from the left support column. You're asked to determine the force present on each of the vertical support columns. To determine these forces, we can write a static equilibrium equation for the horizontal beam. Since the horizontal beam will exert a downward force on each of the vertical columns, we know that each column will exert an opposing upward force on the vertical beam. We can call these force A and force B. We're told that the horizontal beam has a mass of 1,200 kilograms. The weight of the horizontal beam equal to 1,200 kilograms multiplied by the acceleration due to gravity acts at the beam's center of gravity, which is 7.5 meters from either column. In addition, the oven exerts a downward force on the beam equal to 7,000 kilograms multiplied by the acceleration due to gravity. Since the beam is in static equilibrium, we know that the sum of the torques at any location will equal 0. If we sum the torques at the point of force A, we can write the following torque equation. Remember that positive torques act in the counterclockwise direction, and since we're taking the torque about point A, our only unknown will be force B. Solving for force B, we find that it's equal to 3,400 kilograms multiplied by the acceleration due to gravity. Using 9.81 meters per second squared for the acceleration due to gravity, we find that force B is equal to 33,354 newtons. Since the beam is in static equilibrium, we know that the sum of the forces in the y direction will also equal 0. We can use this to find the unknown force A. Writing the following equation and plugging in the value that we just found for force B, we can find that force A is equal to 47,088 newtons. If you wanted to check your answer, you would see that the sum of force A and force B is equal to the combined weight of the horizontal support beam and the oven. If this wasn't the case, you would know that your answers were wrong. It's important to note that what we found are the forces exerted on the horizontal beam by each of the vertical supports. Because the problem asked to find the force present on each vertical support, these forces would actually act in the downward direction. I hope that this video was helpful in showing how you can solve problems involving static equilibrium. While these problems can vary a lot, what you need to know is that you can always sum forces and torques to equal 0. This should allow you to find whatever value the problem is asking for. If you still have any questions, feel free to comment below and I'll do my best to answer them. If you found this video helpful, please give it a like and consider subscribing for more fast physics videos. Thanks for watching.